Hello and welcome to our introduction to gears video. Let's start with the function of gears. The general purpose of gears is to transmit motion and/or power from one shaft to another. In addition, gears have three primary usages in a system. First is speed ratio. By using different sized gears, the input to output rotational speed of shafts can be changed efficiently. The second usage is for adjusting the torque ratio of the system. Lastly, gears are useful means for changing the direction of rotation or converting a rotational motion to a translation motion. At some point, we've all probably seen and used mechanical gears. But are you curious to learn more about gears? We will cover many details about gears in this video, so please stay with us until the end of the video and subscribe to our channel if you enjoy it. In this section, we will go through different types of gear and talk about their main characteristics. Spur gears are the most commonly used gears. They transmit power through shafts that are parallel. The teeth of the spur gears are parallel to the shaft axis. This causes the gears to produce radial reaction loads on the shaft, but not axial loads. Spur gears are usually used for low and medium speed applications, which are usually up to 3,600 revolutions per minute. They are not very often used in high speed applications. This is due to the loud noise they produce at high speeds. The benefits of spur gears are a simple design, cheap production, and maintenance. Helical gears are used with parallel shafts similar to spur gears. However, helical gears have teeth that are oriented at an angle to the shaft, unlike spur gears which are parallel. This causes more than one tooth to be in contact during operation, and helical gears can carry more load than spur gears. Due to the better teeth meshing than spur gears, this makes them a better choice for high-speed applications. Also, they operate smoother and quieter than spur gears. On the other hand, helical gears have sliding contacts between the teeth, which in turn produce an axial thrust of gear shafts and generate more heat. So this makes them less efficient than spur gears due to tooth slippage. Bevel gears have a cone-shaped appearance and are most commonly used to transmit power between shafts that intersect at a 90-degree angle. They can be used at various angles, but most are tried at 90-degree angles. Applications where a right-angle gear drive is required and two shafts cross each other make bevel gears the right choice. Worm gears are used to transmit power at 90 degrees on non-intersecting shafts. Worm gears produce thrust load and are good for high shock load applications. A screw-shaped cut on a shaft is the worm. The mating gear is the worm wheel. The main disadvantage of worm gears is their low efficiency, which can be close to 15% due to the high friction and associated axial stresses. Next on the list, we have hypoid gears. They operate on shafts that do not intersect. The hypoid gear is offset from the gear center, allowing unique configurations and a large diameter shaft. The larger shaft diameter means they can have large pinion diameters and make them a good fit in torque-demanding applications. A rack and pinion is a type of linear actuator that comprises a circular gear, the pinion, engaging a linear gear, the rack, which operates to translate rotational motion into linear motion. Driving the pinion into rotation causes the rack to be driven linearly. The internal gear or ring gear has teeth inside of a ring rather than on the outside. A magnetic gear is similar to a mechanical gear in function but uses magnets instead of teeth. As gear design is a wide area on its own, we will only cover three important topics in this section briefly. We will start with the gear profile and continue with the gear ratio and gear pressure angle in the next sections. One of the fundamentals of gear design is the profile of the gear tooth. Before going any further, let's define a few of the important nomenclature of gear profile as shown in this graph. A pitch circle, shown as the middle circular red line, is the radius of which is equal to the distance from the center of the gear to the pitch point. This is where the gear's speed is measured. Also, it is the curve that outlines the mating point between two gears. Many important measurements are taken on and from this circle. Next is the circular pitch shown with the yellow arrow. This is the angular distance of the teeth along the circumference of a disc. The other important nomenclature in the gear profile is the gear teeth height. The height of the gear is the summation of addendum and addendum shown on the very left of the graph. The addendum is the height by which a tooth of a gear projects beyond the standard pitch circle or pitch line, and the dedendum is the distance between the pitch circle and the root circle. The dedendum is larger than the addendum to assure that the tops of the mating gear teeth can pass the root area without interference. There are more definitions in a gear profile, but we should continue to the next step. For a gear to drive in a given direction and to transmit power or motion smoothly and with a minimum loss of energy, the contacting surface on mating gears must have the following properties. First, the height and the lengthwise shape of the active profiles of the teeth must be such that, before one pair of teeth goes out of contact during mesh, a second pair will have picked up its share of the load. This is called continuity of action. Thus, the height of the gear makes an important role here. Second, the shape of the contacting surfaces of the teeth must be such that the angular velocity of the driving member of the pair is smoothly imparted to the driven member in the proper ratio. Lastly, the spacing between the successive teeth must be such that the second pair of tooth contacting surfaces is in the proper position to receive the load before the first leaves. The circular pitch will be a critical factor to study here. To explain the gear ratio, we need to build a gear train. A gear train consists of 2 or more gears in series. Also, it is necessary to define 2 terminologies as we will be using them frequently. First, when 2 gears are meshed together, the smaller gear is called a pinion. Second, the gear transmitting force is referred to as the driver gear, and the receiving gear is called the driven gear. A gear ratio is the ratio of the sizes of 2 gears. It is calculated by dividing the number of teeth of the driven gear by the number of teeth of the driver gear. In this example, when the pinion drives the output gear, for every 3 turns of the pinion the output gear will complete 1 revolution. This drive mode of gears is called gear reduction. Now, if both the driver and driven gear have the same size, this mode of gear is called direct drive. This means the ratio between the number of teeth if the driven and driver gear is 1. Thus, for every revolution of the driver or input shaft, the driven or output shaft will revolute the same number. Also, in the direct drive mode, the torque transferred between 2 gears are same. The last gear mode is called overdrive. As the name suggests, in this mode the driven gear rotates faster than the driver gear. When a larger gear drives a smaller one, for one rotation of the larger gear the small gear must complete more revolutions, so the output will be faster than the input. For our example, dividing the 10 teeth of the driven gear by the 30 teeth of the driver gear gets us 1/3. This means that the gear must turn only 1/3 of a revolution to get the pinion to make 1 complete turn. Also, in this mode, the output torque will be less than the input torque. So if we want to put all the 3 gear modes in one picture, we can make the following conclusion. Since the rated output power of a motor is a fixed value, speed and torque are inversely related. In the gear reduction mode shown to the left of the graph, a larger output gear is used, thus the output speed decreases and the available output torque increases proportionately. On the other hand, in the overdrive mode shown to the right of the graph, a smaller output gear is used, and this causes the output torque to decrease and the output speed to increase proportionately. So in conclusion, one of the primary purposes of the gear ratio is to increase the torque by reducing the speed and vice versa. This characteristic of gears provides engineers with the option to select different gear sizes in the design process of a device depending on the speed and torque requirement of the application. The other important aspect of gear design is the pressure angle. Pressure angle is the angle between the tooth face and the gear wheel tangent, and it gives the direction normal to the tooth profile. This angle is formed by the common tangent to the pitch circle shown with the horizontal black line in the graph and the line tangent to the base circles of the mating gears, also called the pressure line. The pressure line is normal to the tooth profile and can be shown in the graph by drawing a red line passing through points A and B. It is important to note that if the gear is positioned at the center of the graph, the angle between the horizontal black line and the red line is the pressure angle. A common value of 14.5 degrees was historically used in diametral pitch gearing. The basis for this selection was that this pressure angle allows for reduced noise in the gear mesh and exhibits a lower rate of wear. However, it was recognized by American Gear Manufacturers Association that a 20-degree pressure angle was more suited for most applications. The benefits of selecting a 20-degree pressure angle include additional power transmission capacity, better lubrication in the gear mesh, and reduced numbers of teeth for the pinion without undercutting. The 20-degree pressure angle gear tooth has a wider base that allows for additional load capacity, but it incurs additional wear on the tooth flank during the interchange of teeth in and out of meshing. For some special applications where noise is not an issue but strength is, a larger pressure angle of 25 and 30 degrees can be used. Now let's put each of the explained gear types earlier in this video in a real-life application to demonstrate its function in the system. We will create a separate video for each of these applications later, so please make sure to subscribe to our channel to be notified when they are available. One of the common applications for spur gear can be found in hydraulic pumps. In this example, we are showing you an external gear pump. An external gear pump utilizes two identical spur gears meshed side by side. The top gear is driven by a motor and it drives the bottom gear. Each gear is supported by a shaft with ball bearings on both sides of the shaft. Fluid trapped between the gear teeth is displaced from the inlet, shown with blue arrows in the animation, to the outlet port, shown with red arrows. The gear mesh at the center will act as a seal between the ports. Helical gears are used with parallel shafts similar to spur gears. However, helical gears have teeth that are oriented at an angle to the shaft. The gear teeth orientation is called the helix angle and is measured from the center axis of the gear as shown in this illustration. The helix angle for single helical gears is between 12 to 20 degrees. The helix angle causes more than one tooth to be in contact during operation, and helical gears can carry more load than spur gears. Due to the better teeth meshing than spur gears, this makes them a better choice for high-speed applications like inside vehicle transmission. A vehicle transmission is made up of a series of helical gears. The transmission takes power from the engine and delivers it to the wheels to help power the vehicle. In the next example, we will show the application of bevel gears inside a differential of a vehicle. Simply, a differential is a system that transmits engine torque to the wheels. It takes the power from the engine and splits it, allowing the wheels to spin at different speeds. The engine-to-wheel connection configuration requires the differential to transmit the torque with a 90-degree angle as shown in the animation. For this reason, bevel gears are a perfect fit to be used in a differential. Next, we have the hypoid gear, which is generally used in the rear drive axle of trucks. The rear drive axle is located between the differential and the driving wheels and transmits power between them. As explained earlier, the hypoid gear has an offset from the spiral gear. So what is the benefit of the offset? The reason for the offset is to lower the center of gravity and avoid a bigger propeller shaft tunnel. The hypoid offset causes a relative length sliding between the meshing flank surfaces and enlarges the diameter and spiral angle of the pinion. This leads to an additional dampening in the tooth mesh, increased contact ratio, and improvement in pinion strength. In addition, a larger diameter shaft can be used in hypoid gears, which enables the engineers to use larger pinion diameters. This makes hypoid gears a good choice for higher torque demanding vehicles such as trucks. Have you ever wondered how your luggage is delivered to you at the airport within minutes, or how thousands of items are transported in a factory with minimal effort, thanks to conveyor belts for making this possible? The belt on the conveyor is the platform for transportation, but what components enable it to deliver linear motion for its transportation? To understand this, we should take a look inside the gearbox of a conveyor belt. Inside the gearbox, you can see a worm gear set. The worm gear is the primary component, and it uses a screw shape to turn the worm wheel, which translates the rotational motion to a linear motion. Also, the other purpose of using worm gearboxes is to reduce speed to slow down conveyor belts and in the meantime transmit higher torque from the electromotor. Next up, let's take a look at an example most people interact with on daily basis: the steering wheel of a car. The steering wheel assembly primarily controls the direction of a vehicle. But what type of gear enables this motion? The rack and pinion is a type of steering mechanism with a pair of gears that convert the rotary motion into linear motion. This system consists of a circular gear called pinion that engages with the teeth on the linear gear shaft called the rack. If we look inside the steering mechanism, it consists of a pinion at the end of the steering column that meshes with the rack. The pinion is fixed to the steering column at its end. It meshes with the rack, which moves either to the right or the left side depending upon the movement of the pinion. One of the common places that internal or ring gears are used is planetary gears. Planetary gears are often used when space and weight are an issue, but a large amount of speed reduction and torque are needed. This requirement applies to a variety of industries, including tractors and construction equipment, where a large amount of torque is needed to drive the wheels. Other places you will find planetary gear sets include transmissions of helicopters, turbine engines, automatic transmissions, and even electric screwdrivers. Planetary gear systems are able to produce a lot of torque because the load is shared among multiple planet gears. This arrangement also creates more contact surfaces and a larger contact area between the gears than a traditional parallel axis gear system. Because of this, the load is more evenly distributed, and therefore the gears are more resistant to damage. A magnetic gear is similar to a mechanical gear in function but uses magnets instead of teeth. Here you can see the main components of a magnetic gear. The gears don't touch at all, they only interact magnetically, which makes them unique. The gear ratio is determined by the number of magnets used in each rotor. Magnetic gears are relatively new in the industry. In recent years, the magnetic geared motor has emerged as an interest in electric vehicles and electric bikes. We briefly covered the applications of gears in real engineering applications. However, there are more details that need to be covered to understand their functions. So, we will be creating videos for each of these examples individually and will cover more details about them. We hope you enjoyed this video. Please stay tuned for more videos by subscribing to our channel. Goodbye.